get started. We've got a lot to get through today. Welcome, my name is Tony, and I'm your instructor for the first half of your 2-day training course. So I'm going to swap over with a good friend and colleague of mine, Jeremy, tomorrow, mid-morning, and he's going to take you on another journey with Boomi AI. This is me, quick introduction. I hail from London, England, that's Old England. For you, anyone here from Texas, the putting green across the European moat that your president calls it now. In my varied career, I've worked for IBM originally, Oracle, teaching middleware, and before that BEA Systems, if anyone remembers that, good old Java to enterprise servers. Outside of work, I love to travel. Lockdown put paid to a lot of that, but anyway, we're getting back into it now. Music, the theatre, and I have a passion for sci-fi, science fiction. I live right in the middle of England, in a county called Northamptonshire. Very picturesque, as you can see here. Lots of green fields, very agricultural, rural. We have, this pointer doesn't work on a monitor. We have old cottages like that in villages with thatched roofs. If you've ever heard of those are made out of straw, and they're still going today. They have to be renewed every 30 years. It's a dying art. Being only 1 day's coach ride from, and I'm talking horse coaches, from London in the Industrial Revolution. The landed gentry were always here, of course, but the industrialists set up home in this county. And some of them earned a lot of money. And now, of course, a lot of these houses are sold because they can't afford to keep them going. So I bought this one here. Actually, no, this is one of my neighbours. It's owned by the Duke of Buccleuch. And just to give you an idea, it's about 10 minutes from my house. He has a window in his house for each day of the year. Just to give you an idea. Yeah. Northamptonshire is also the home of Formula 1 in Great Britain. Silverstone, if you've ever heard of it. They do the annual Formula 1 Grand Prix there. A lot of the teams are based in and around Northamptonshire. So, that's me. As I mentioned, the training is in 2 parts. The first bit this afternoon and the first bit of tomorrow, we will talk about retrieval augmented generation from first principles. And then afterwards, Jeremy will take over with a more advanced application of RAG, as we call it. Now, what are we expecting you to do? So I'm just talking about my half now. We're expecting you to be able to understand what we mean by generative AI and its core principles. We hope that you will learn about retrieval augmented generation, what makes it different, why we use it, and the specific challenges that it poses, and address those. And we're going to be using Boomi templates called recipes for building a functional RAG solution. So this is the sort of layout of the first half of the course. We'll start on the first page and try and understand what AI is from our perspective and why, how we've got here. And then I'll draw the distinction between AI in Boomi and AI with Boomi. Then we'll get into using, we're going to use ChatGPT today, but we're going to use it through an API from Boomi, so the chat completions API. We'll learn more about large language models and some of their limitations and how we can what we call ground them in real life. and then we'll get stuck into retrieval augmented generation and how to implement it with Boomi. I want to spend a few moments at the end of tomorrow morning explaining, now we've learnt that, what do you do next, where to go, what kinds of things do you need to consider. So, how can Boomi help harness the awesome power of generative AI? The goal of this particular training is to demonstrate the effective use of AI in a particular use case. And we're going to use a chatbot because a lot of people are familiar with chatbots. This is not to say that your use case has to be based around a chatbot, absolutely not. And Jeremy will show you an example of using RAG without a chatbot in the site. We're going to demonstrate the use of Boomi recipes. Anyone who here has used Discover or Marketplace? Downloaded some recipes. Okay, I thought there'll be more of you than that. We'll do one this afternoon and provide how it provides the foundations for your continued development of your applications. And to do that, we are going to retrieval augmented generation. We're going to locate and prepare relevant technical documentation. Maybe it's help desk data, maybe it's FAQs, maybe it's a record of our call centre questions and answers, whatever it is. We'll find a way of storing that so that we can retrieve it rapidly and appropriately, and then use that retrieval to augment the question that we ask the chatbot. The aim is to have a much improved chatbot response. On the way, you will see Boomi in use in a lot of ways. For accessing the source data, for orchestration, classic use of Boomi. Accessing an API, various APIs, chat completions API for one. We're going to be using embeddings for vectorizing. We're going to be using a vector database in the shape of Pinecone. And of course, all the time you'll be using Boomi in tried and tested ways for rapid iterative development and testing. Why? You can do this using a lot of tools. Well, of course, Boomi has a number of advantages. One key thing is you are developing once, and then you're able to test and deploy to a scalable production environment. It's grown up from its beginnings as a fully functional integration engine, so it's ideal for orchestration. So let's get on the same page, very quickly introduce what we understand to be AI, artificial intelligence. It's been around, as I'm sure you're aware, in the IT industry since the 50s, but it's only recently, relatively recently, entered public consciousness. Around the end of 2022, with the launch of the ubiquitous ChatGPT from OpenAI. Since then, recent advances in machine learning have led to huge breakthroughs in capabilities. Capabilities of access and capabilities of ease of use of AI. And it's this combination, this coming together of technologies at a particular point in time that's having this profound impact. Rather like the way that we saw mobile technologies come together in what we have now as smartphones. Now, artificial intelligence is a broad umbrella term. It encompasses all sorts of different technologies that imitate human intelligence. You could think of originally AI as logical scripts from the 1960s, or a tangible physical robot, or a verbal assistant like Alexa. For our purposes today, artificial intelligence is basically a highly capable IT system created by humans that can mimic various human abilities, such as understanding language, making decisions, and learning from data. It operates typically through programs and algorithms, not physical machines. And it can often be seen working in the background to assist tasks such as suggesting words whilst typing, or providing personalised recommendations and user preferences. So if artificial intelligence is the goal to what we want to achieve, then machine learning is how we get there. If we think of AI as an umbrella term, then machine learning is a subfield of artificial intelligence. ML, machine learning, involves training computer systems to recognise patterns and make predictions by processing data through algorithms. It's particularly valuable for solving complex problems such as image recognition and language translation. And it stands out from other technologies in that it's capable of improving itself, self-learning, by running more data through more patterns and more iterations, typically millions and millions of iterations. So this is radically different from the more traditional computer systems that have to be programmed with a specific set of rules. Machine learning relies on masses and masses of digitized data. And it's only, again, thinking about the confluence of technologies, the recent advancements in computer hardware speeds and capabilities that make it cost effective today. Under the category of machine learning, there are probably 1,000 different specialised technologies. Image recognition, language translation, data manipulation, data analysis, data visualisation, and so on. But one in particular is of interest to us: neural networks. These imitate the designs of neurons in a human brain. It trains itself, the network trains itself by looking at the outcome of previous processes, and then going back and changing the weight, i.e. the importance or the priority of the neurons within it. And this mimics how our own memory stores information and patterns. This technique is called backpropagation. There are many articles explaining this if you're interested on the web. As the network learns and improves, the different nodes will be given more or less weight, determined by how they contribute to the outcomes. Now, there are a couple of AI technologies that apply to what we're learning about today. First is natural language processing. And it's within that discipline that large language models come, which use many of the AI technologies today. Natural language processing, NLP, is essentially the understanding and processing of human language in whatever form it's presented: written, spoken, typed, even scribbled. It analyses the grammatical structure of sentences and individual meaning of words, and then uses its algorithms to extract meaning and deliver outputs. In other words, it makes sense of human language so that it can automatically perform tasks. Probably the most popular examples of NLP in action are virtual assistants like Google Assist, Siri, Alexa, and of course chatbots. But it's used in many other everyday applications, such as text recommendations when writing an email, or offering to translate a Facebook post written in a different language, filtering unwanted promotional emails into your spam folder, Now we come to a key technology, which is accelerating the capabilities and adoption of AI. And that is large language models. History teaches us that sometimes combining two or more technologies at a point in time leads to a giant leap forward in capabilities. Think of the integration of GPS technology into smartphones. It revolutionized navigation and location-based services, and it gives us real-time mapping, navigation assistance, and location-based advertising. Think of the convergence of 3D printing technology and biotechnology has enabled the creation of bio-printed tissues and organs for medical purposes. And in our field, it's the combination of neural networks and natural language processing that's given us a quantum leap forward in capabilities, large language models. These are based on neural networks. They use machine learning to process and mimic human language communications and perform tasks like translation and content generation and summarization. Whilst lacking consciousness and emotions, they often sound human-like because they can fine-tune their outputs, their results, through reinforcement learning from human feedback. How do they work? How are they trained? What can we use them for? Let's hear from Chris Capetta, one of our solution architects working on innovative AI solutions.
Hello there. Today we're going to take a quick look at large language models. We're going to take a look at what they're doing, we're going to look at how they're trained, and we're going to take a look at why they might be useful. So, what are they doing? Effectively, they are mimicking human text by predicting the next token, effectively the next word. In the old days, last year, a token was a smaller section of a word, so the phrase "hello world" would be something like this. 4 tokens there. The more current models at the leading edge seem to be using entire words as a token, so something more like this these days. So how are they trained to do that? It happens in a number of steps, and we'll probably do a different brief on that at some point, but the first step is called pre-training, and you're effectively compressing a huge amount of information down to a much smaller size. It's not intended to save all of the original information and serve as a reference to all of the original information. It's using that to teach the neural network how to predict the next word. So it's important to understand that it's sort of a lossy compression that isn't necessarily a reference to all of the original information. So that's the first step, and it's called pre-training, and then there are a number of other steps to basically fine-tune it to act more like an assistant and respond to questions and that sort of stuff. So there's my funnel showing the World Wide Web compressed down into a large language model. So finally, why would you use them? Well, lots of reasons, and lots of people are finding different valuable aspects to them. Personally, I find they're very useful to help summarize large documents. I develop a fair bit of software, so it's remarkable how well they are at helping me generate code. I don't really have to know the syntax of a given mechanism that I'm trying to do. I just need to know how to coach the LLM to generate the thing that I want. And then finally, it's just a really good dialogue companion to work through an idea or a design or something like that. You can give it ideas, it'll bounce stuff back to you, and in that way you can get to a good outcome pretty capably. So I like to think of it as handling the grunt work. It is important, I think, still to keep a human in the loop, though. The models, at this point, they can say wrong things, they can kind of get lost and mixed up a little bit, so I like to think of them as a tool used by humans and wielded by humans, rather than necessarily something that acts on its own. Thanks for watching. I hope that was valuable.
Okay. Thank you, Chris. Finally, using large language models, we have a new technology, generative AI. Again, building on the capabilities of all those previous technologies. And it's really brought AI into the mainstream. Suddenly businesses and governments alike are sitting up and taking serious notice. Gen AI uses large language models to create new content rather than just repeating existing content. It can work on multimodal and create content in various forms, such as images, music, text, video, and even code. And here's some examples. Has anyone played with Day1 for image? Yeah, content generation. In fact, we've used AI ourselves to generate the icons in our course. In the interest of time, I won't show you this video, but it's an example of a full 4K quality video that's been generated using a tool like Day1. It's very impressive. There are a large range of models. These are just the ones from OpenAI, and in fact, I forgot to check this slide. Give it 2 weeks and it's out of date. There will no doubt be other models as well for doing other specific tasks. And of course, being rapidly developed are the multimodal models, which can work with different types or modes of data simultaneously. Really powerful. Example, it can look at a picture, a portrait, listen to sounds and read words. And it can combine all this information to do things like answer questions about images. And I don't need to tell you about the power of large language models for generating code. This particular example I saw on the internet. The author took a screenshot of a dashboard and asked, I can't remember which code it was, here he is, McKay Wrigley, ChatGPT to generate code for it. And then he tried running it and he says it's near perfect, came out, frightening. We don't have this in the UK, but you have the Circle here in the US. And I can't remember what it was last year, 2024. Unbeknown to the contestants, they had a generative AI contestant. And this was hidden from the other contestants until they told them about it towards the end. So for several weeks it acted as a real contestant. I think Heinrich here has some good things to say about generative AI. Brings together a lot of key learning points. So I think it's worth listening to Heinrich if we can get it going. Stop the adverts. What? You're joking. Sign in to prove you're not a bot. What?
It's gonna be harder.
You are joking. And it's not allowing me even to sign in. I apologise. We're not gonna hear that video. Looks like it's been disabled for some reason. In summary, he's telling us it's here. We've got to learn to live with it. We've got to learn to work with it. Some jobs are going to go, particularly Tom's. What's different between this and other past revolutions is the speed of change and the huge scope for AI applications. It's got a huge potential to transform business work, teamwork, generating AI content. Who uses this for summarization of meetings, notes, yeah? Writing emails rapidly? Sure. Yeah, of course. But you need to be aware, of course, of the limitations and dangers. The biggest limitation really is our imagination. And the age-old maxim still applies to AI. I've been in the industry for over 50 years. And do you remember GIGO? Garbage in, garbage out? Same thing applies to AI. But you can improve the response of AI through experimentation and iterative development. It's important to become skilled at prompt engineering. Putting prompts together. More to talk about that later. I mentioned that AI follows previous technological revolutions. The car, of course, replaced the horse. And mobile phones, and especially smartphones now, replaced a whole range of tools that we had. Okay. Let's just skip ahead here. I mentioned the speed of change. I mentioned earlier that ChatGPT has probably done more to bring AI into the mainstream of user and acceptance and stir the public consciousness than any other product. If you measure it by its ease of use and wide availability. Now you may have seen this graph before, but these different technologies when they're introduced, 78 months, 70 months, Uber, Telegram, whatever. ChatGPT achieved, 100 million users in 2 months, which is an incredible acceptance rate. Okay. Does it make sense? Any questions so far? I wanted to draw the distinction between